Our planet is sending us a clear message. The climate is changing and our reliance on fossil fuels is the primary cause. For generations, we have burned coal, oil, gas. We use that energy to power our homes, our cities, our industries. This has released vast quantities of carbon dioxide into the atmosphere, wrapping our world in a warming blanket. The consequences are now impossible to ignore. We see rising sea levels, more extreme weather events, ecosystems struggling to survive. The need for a fundamental shift in how we generate energy has never been more urgent. We must turn to cleaner, more sustainable sources of power that work in harmony with the natural world, not against it. The wind is a powerful and abundant source of clean energy. For decades, we have harnessed its strength using magnificent spinning turbines. These familiar structures, with their vast rotating blades, have become symbols of our transition to a greener future. They stand tall on rolling hills far out at sea. In many ways, they are a triumph of engineering, a testament to our ability to innovate in the face of a global challenge. These wind farms are a crucial part of the solution, providing significant amounts of power without producing harmful emissions. They represent a vital step away from the polluting energy sources of the past. However, these conventional wind turbines are not without their limitations. Their sheer size makes them expensive to build, transport, and install. The enormous blades, which can span the length of a football field, create a significant visual impact on the landscape. They also produce a constant low-frequency noise that can be disruptive to nearby communities. Furthermore, the fast-spinning blades pose a known risk to birds, bats. These issues often make it difficult to place turbines where they are needed most, particularly in populated areas or ecologically sensitive locations, creating a gap in our renewable energy arsenal. While traditional turbines are excellent for large-scale, open-area generation, they are not a one-size-fits-all solution. Many places with consistent wind, such as cities, residential areas, and protected natural parks, are unsuitable for these colossal machines. We need another way to capture wind energy, a method that is quieter, safer for wildlife, and less visually intrusive. The challenge is to find a design that can operate effectively on a smaller scale, fitting seamlessly into the diverse environments where people live and work. The search is on for a new kind of wind power, one that can fill this critical gap. The solution may come from a surprising place, not from making bigger and faster blades, but from getting rid of them altogether. Imagine a wind turbine with no spinning parts at all. This is the core idea behind the Vortex bladeless turbine. Instead of using rotation to generate power, this innovative concept uses oscillation, or a gentle side-to-side swaying motion. It is inspired by vortex shedding, a physics phenomenon engineers often try to avoid. This radical rethinking aims to solve many problems of traditional turbines. It offers a quieter, more discreet, potentially safer way to harness the wind's energy. This essay will guide you through this fascinating technology. We will begin by exploring the problem in more detail, looking closely at how conventional wind turbines work and why their limitations matter. Then we will introduce the Vortex bladeless concept as a direct response to these challenges. The core of our journey will be to understand the physics behind this new approach. We will explain how a simple mast can be made to oscillate by the wind, a process known as vortex-induced vibration. This natural swaying motion, when properly controlled and amplified, becomes a powerful source of renewable energy, turning a potential structural problem into an elegant solution. We will then break down the device itself, examining its key components. You will learn about the slender mast, the specially designed resonator, the generator that converts motion into electricity, and the base that holds it all together. We will also look at real-world examples and performance data from prototypes and pilot projects. This will give us a clear picture of how much energy these devices can actually produce and how efficient they are compared to their bladed counterparts, providing a grounded view of their current capabilities. Finally, we will weigh the pros and cons. We will compare bladeless turbines to traditional ones on crucial factors like safety, cost, maintenance, its renown where they can be installed. This balanced assessment will address the challenges the technology still faces, such as improving its efficiency and proving its long-term durability. By the end, you will have a comprehensive understanding of Vortex bladeless turbines. You will see that while they may not replace large wind farms, they represent a clever and complementary tool in our quest for a sustainable future, capable of bringing wind power to places it has never been before. The table of contents follows. The most common wind turbine design is the horizontal axis wind turbine, or Shadoti. Its blades aren't simple paddles. They are shaped like airplane wings. When wind flows over them, it creates lift, causing the blades to rotate. This rotation turns a shaft, which is connected to a gearbox that increases the speed. This high-speed rotation drives a generator, converting mechanical motion into electricity. But while powerful, their immense scale brings significant challenges. A single turbine can cost millions, and transporting the enormous components is a major logistical undertaking. Their towering presence alters landscapes, while the noise and high-speed blades can disrupt residents and harm local wildlife. These impacts often create opposition, halting projects and leaving a critical gap in our ability to deploy wind energy everywhere. We need a technology that can operate safely and discreetly where large turbines cannot go, complementing our existing wind farms. This quest sets the stage for a radical new idea, a turbine with no blades at all. The Vortex bladeless turbine works on a principle engineers historically tried to prevent: vortex-induced vibration. As wind flows past the mast, it creates swirling whirlpools of air called vortices. These detach from alternating sides, creating low-pressure zones that pull the mast back and forth, causing it to sway. This same force famously destroyed the Tacoma Narrows Bridge. But instead of fighting it, the bladeless design harnesses this destructive power for clean energy. The key is resonance. The mast is tuned to a specific natural frequency. When the vortex shedding matches this frequency, the swaying is dramatically amplified, a phenomenon called lock-in. It's like pushing a swing at just the right moment to make it go higher. This powerful oscillation is then converted into electricity. A linear generator in the base uses magnets attached to the moving mast. As they sway past stationary copper coils, they induce an electric current. The system is elegantly simple: a composite mast designed to oscillate, a tuning system to achieve resonance, and a generator to convert that motion into power. For safety in high winds, physical bumpers limit the sway, and an electromagnetic brake can stop the motion entirely. By embracing the wind instead of resisting it, the turbine generates energy with no blades, gears, or bearings. After exploring the theory, we must ask the crucial question: How well do these bladeless turbines actually perform? The answer comes from data gathered from prototypes and small pilot projects. For the smaller units developed so far, the power output is modest. A single device might generate a few dozen watts or a few kilowatts depending on its size and the wind conditions. This is far less than a single giant conventional turbine, but that is not a fair comparison. They serve different purposes. The efficiency of a wind turbine measures how much kinetic energy in the wind becomes electricity. Traditional horizontal axis turbines can reach efficiencies of up to 50%. Early vortex bladeless prototypes show lower peak efficiencies, typically around 30% up to 40%. Another important metric is the capacity factor. Bladeless turbines have a lower cut-in wind speed, so they start generating in lighter breezes than many large turbines. That can raise capacity factor in gentle but steady winds. Engineers are continuously working to refine the design, improve the efficiency of the linear generator, and optimize the control software that tunes the device to the wind. Its most promising application is in distributed microgeneration. Imagine slender masts on rooftops of office blocks. Imagine slender masts on apartment buildings. Imagine slender masts on shopping centers. Quiet operation and low visual profile make them acceptable in dense urban areas. These devices are perfectly suited for remote off-grid applications. Think of a remote scientific research station. Think of a telecommunications tower on a mountaintop. Think of a solitary cabin deep in the wilderness. Another ideal use case is along transport corridors, highways, railways, bridges. The compact, safe design means they could be installed without risking traffic. This could power lighting, this could power traffic signs, this could power monitoring sensors. Finally, the bladeless design opens up possibilities in ecologically sensitive areas. Because they have no external moving blades, they are inherently safer for birds and bats. Their silent operation would also minimize disturbance to wildlife. The potential cost advantages of vortex bladeless turbines are a key part of their appeal. The simpler manufacturing process and lower maintenance costs could make lifetime cost of energy very competitive. Despite its elegant design, the vortex bladeless turbine faces several significant hurdles. The primary technical challenge remains its lower peak efficiency. Another major technical concern is the long-term durability of the mast. Beyond the engineering, there are also regulatory and social hurdles. Because this is a new type of technology, it does not fit neatly into existing planning regulations and building codes. Education and demonstration projects will be essential to show communities the benefits. Our journey began with a clear problem. Magnificent spinning turbines symbolize clean energy, but they are not a universal solution. Their immense size, the noise they produce, their high costs, their unfortunate impact on wildlife. The vortex bladeless turbine offers a truly ingenious answer. It turns vortex-induced vibration into useful power. Instead of rigid rotating blades, it dances with the wind. No spinning blades, virtually silent operation, vastly reduced risk to birds and bats. A slender, unobtrusive form with minimal visual impact. But keep a realistic perspective. Not a silver bullet for the global energy crisis. Not meant to replace gigawatt wind farms. Rather, a complementary, specialized tool to fill an important gap. The immediate path forward involves persistent engineering and testing to refine the design. The goals are clear: to increase the efficiency of energy capture, to reduce manufacturing costs through scale production, and to prove the long-term reliability. As the technology matures, it will integrate more closely with other renewables, pairing with solar panels, pairing with battery storage. A hybrid system provides reliable power around the clock. These localized microgrids can offer true energy independence for homes, businesses, and entire communities, making them more resilient to grid failures and reducing the strain on our aging electrical infrastructure. The move from promising prototypes to widespread use is a collective effort. It calls for continued investment from the public sector, continued investment from the private sector to support the research, development, and deployment needed to help it reach its full potential. By encouraging and supporting this innovation, we can help the Vortex Bladeless turbine fulfill its promise to provide a quiet way to dance with the wind, a safe way to dance with the wind, a gentle way to dance with the wind, generating clean power for a more sustainable world.